For this problem, we're looking for the probability of obtaining a sample mean that's greater than 97 when we know that the population of IQ scores form a normal distribution with a mean of 100 and a standard deviation of 15. So let's start again by writing down what it is that we know and then make a rough draft of the area that we're looking for. So for A, the mean is 100, population mean. The population standard deviation is 15. And we're looking for the probability of a mean that's greater than 97. So this is what this would look like in the rough draft. We know the population mean is 100. And we're looking for the probability of obtaining a sample mean greater than 97. So we know 97 is below 100, so it's on this side over here. And a sample mean greater than would be everybody on this side. So this is what the rough draft looks like. We already know that this is always a proportion of 0.500 because that's half of all the distribution. So we literally just need to find the proportion for this, and this we're going to do again with a C-score. So we write the formulas down. And we know the formula for the standard error of the mean. It's just the standard deviation over the number of people, the square root of the number of people. We know that is 15, and for A we have 9 people, so that's a square root of 9, so that's 15 over 3. So we get a standard error of the mean of 5. Now we just need to plug this down here. So for room reasons, let me just go and finish this up here now. So we know that C equals the mean, which is 97, minus the population mean, which is 100, divided by the standard error of the mean, we just calculated, of 5. So that is negative 3 over 5, which is negative 0.60. So now we have a C-score of negative 0.6. And that's right, because it's negative, because it is located on this side. Right? It's located below the mean. So now let's see what is the proportion between this C-score of negative 0.60 and the mean. For that, again, we need our table. And here we see we have the C-score 0.60. So now it's which column do we use? Well, here you see this is the proportion between mean and Z. So the proportion is between mean and Z, so mean here and Z here. This right here is 0.2257 according to the table. But that's just in between here. So now we still have to add these together, right? We have to add this whole side, which we know is 0.500, and that's how we get the proportion of 0.7257. So that is the whole area here. That is anybody, or the probability of obtaining a sample mean greater than 97. This is the answer for A. And for B, we're doing exactly the same thing. You can just see now that it's saying for a random sample of 25. So we increase our sample size. So for B, everything else stays the same, just our N increases. So now we just have, we still have the 15, but now we increase it to N is 25. So now we have 15 over 5, which is going to be 3. So our standard error decreased, right? It was 5 before, now it's 3 because we increased our n. We have a larger sample now, right? Increase of n reduces the standard error of the mean. Now again, we have to plug it in here. So we still have the 97 minus 100 on the top, but now we have it over 3, which is negative 3 over 3, which is negative 1. So now, again, our drawing would be the same as it was before. Population mean is 100, our 97 is here, and we are looking for the probability of obtaining a sample mean greater than 97, so it's still everybody over here in this direction. Again, now we look up for a C-score of 1, which is right here. Again, we look for between mean and C is 0.3413. So this is 0.3413. We know this is 0.5. If we add this up, we get 0.8413. So the probability of obtaining a sample mean greater than 97 when we have a random sample of 25 people is 0.8413.